All right, we are on the edge of a really huge shift in how AI learns. We have to move beyond just, feeding it endless streams of data. So today, we're going to explore a whole new playbook that teaches AI not just to answer questions, but to actually understand them.
So let's start with a question that keeps pretty much every AI developer up at night. You've got this incredibly powerful model, something like GPT-4, you ask it a question, and it spits back a completely wrong answer with total confidence. This thing, hallucination. It's the single biggest barrier to trusting these systems. So why on earth does it still happen? Well, a big piece of the puzzle is how we give these AIs information in the first place. The standard method is called retrieval augmented generation, or just RAG for short. The easiest way to think about it is like giving the AI an open book test. It gets to look up info from an external source before it gives you an answer. Sounds pretty good, right? What could go wrong?
Well, the problem is in the whole approach. Traditional RAG basically treats the AI like a sponge. It just soaks up whatever information it's given, good, bad, totally wrong, without any real way to process or understand it. And this passive, sponge-like method is really hitting a wall. It's leading to shallow answers and, you guessed it, those super frustrating hallucinations.
So what's the fix? Well, it's a fundamental shift in our thinking. We need to stop treating AI like a passive bucket for data and start building systems that enable active knowledge acquisition. We're talking about an AI that learns how to construct its own knowledge.
So how do we actually go about building this smarter AI? Well, the inspiration's pretty incredible. It comes straight from the most powerful learning machine on the planet, the human brain. We're talking about a way to learn that's directly inspired by how you and I build understanding.
The whole idea is rooted in a learning theory called constructivism. And it basically says that we humans don't just absorb facts like a sponge. No, we actively build our understanding by connecting new information to stuff we already know. It's all about context. So the big question became, what if we could teach an AI to do that? And that is exactly what this new framework does. It's called ActiveRAG, and it is designed from the ground up to transform a large language model from just a passive listener into a truly active learner, one that genuinely builds its own, much more solid understanding of the world.
So, the big question is, how does this actually work? Let's open up the ActiveRAG playbook. And this isn't magic, it's a carefully engineered three-step pipeline for building a way more intelligent AI.
The three main stages are, first, knowledge construction, which is all about preparing the information. Second is dynamic retrieval, where the AI can go look for new facts if it needs to. And third, the most important part, is what's called the cognitive nexus. This is where the AI actually, thinks.
Okay, let's start with step one, knowledge construction. See, instead of just dumping a whole library of raw, messy documents onto the AI, we pre-process that knowledge. We turn it into these highly structured, purpose-built assets. So we're not giving it a messy library, we're giving it a set of curated textbooks.
And this table here breaks down the three types of textbooks that we create. First up, we have epistemic anchoring documents. Think of these as a combination of a dictionary and an encyclopedia. They give the AI the basic definitions and context for brand new ideas. Next are logical reasoning documents. These are kind of like logic puzzles. They teach the AI how to connect cause and effect using simple if-then statements. And finally, you've got cognitive alignment documents. These act as the ultimate fact checker, helping the AI spot contradictions and correct its own mistakes before they become hallucinations. So, when you put these three documents together, what you're really doing is providing the AI with a cognitive roadmap. It gives the AI a clear, structured path to follow as it learns, instead of just letting it get lost in a sea of random raw data.
Okay, but what about brand new information? Stuff that's happening in real time? That's where step two comes into play. The system can still use that traditional RAG method to go pull fresh data. But, and this is a big but, it only does it as a dynamic action when its cognitive roadmap isn't enough. It's a specific tool, not the default way of doing things. And all of this brings us to the final and honestly the most revolutionary step, the cognitive nexus. This is where we literally force the AI to think. First, it generates an initial answer, sort of its first draft or gut reaction. But then, and this is the absolute key, it's forced to pause and reflect. It actively goes back and checks its own reasoning against those structured foundation documents, verifying its logic and correcting its own work before it gives a final answer. So this all sounds fantastic in theory, but does it actually work? What are the results? Well, this new approach comes with a pretty big payoff, but it also comes with a price. So let's break down the benefits and the trade-offs. The numbers really do speak for themselves here. In direct, head-to-head tests, ActiveRAG showed over a 5% improvement in accuracy compared to the very best traditional RAG models. Now, 5% might not sound like a huge number, but in the world of AI, a 5% jump in accuracy is a massive leap forward. And as you can see from this chart here, it's a really consistent and measurable improvement across the board. That's the power you get when you shift from just passive data soaking to active, structured learning. But, and there's always a but, this more advanced thinking comes at a price. Unlike a simple one-shot query, the ActiveRAG framework has to call the AI's API 3 separate times. Once for its initial thought, once for its research and verification, and a final time for its refined answer. And every single one of those calls costs time and money. So here it is, the strategic trade-off. On the one hand, what you get is superior accuracy, much deeper understanding, and way fewer hallucinations. But on the other hand, it means higher latency. It's slower, it has increased API costs, and it's just more complex to set up. But here's the bottom line. For any high-stakes application, we're talking medicine, finance, law, where accuracy and reliability are absolutely non-negotiable, this is a totally justified trade-off. It's the difference between an AI that just repeats information and one that genuinely understands it. And this whole thing leaves us with a really fascinating final thought to chew on. This entire framework is inspired by how we humans learn. So if we can successfully teach AIs to think more like us, to reflect, to self-correct, to build knowledge from the ground up, what's the next great problem they'll be able to solve?